Hello, this is Mr. Henry, and welcome to lesson 13.7. In this lesson, we're going to be interpreting and making stem and leaf plots and histograms. The essential question says, how do I interpret stem and leaf plots and histograms? So we've got to get the goof down there. We've got two sets of data, and the question is asking us for which set has a wider range of values. Now, to me, if you're talking about the wider range of values, it means from the biggest number to the smallest number, which one has more of a range? Well, that would be the range of a set of numbers. So the range of this set of numbers is the biggest number minus the smallest. So the biggest number in set A is 2502, and that would be the smallest. So to find the range of the set of numbers, you do a subtraction. Let's just do it by hand. 2502 minus 2432. Subtract 0 and 7 and 0, 0. So the range of set A is 0.7. So from the smallest number to the biggest, there's 0.7 numbers in between. And as far as set B is concerned, the biggest, the smallest, and we've got 53.24 and 52.90, and subtract, I got a range of 0.34. So which of these has a wider range of values? Well, it's going to be set A. Set A has a range of 0.7, while set B has a range of 0.34. So set B, the numbers are closer together. Set A, they're farther apart. We've got a couple vocabulary words here, 4 of them to be exact. The first is a stem and leaf plot. Now, a stem and leaf plot displays data and organizes it based off their digits. Really, it's just a little bit simpler way to organize numbers. If you have a set of numbers, to put it in a graph, but it's not a bar graph, it's not a stem and leaf plot, it's not a scatter plot. It's just a way, if you have just a set of numbers, to represent it in a more compact way, a little bit easier to understand and organize. Now, these next 3 words are talking about a histogram. Histograms are another way to show a set of data. And the first thing you have to do to make a histogram is you have to find the frequency. How often certain numbers happen within certain ranges. Once you find the frequency, you put all that information into a frequency table. The frequency table is used to group data values into equal intervals. And after you've made the frequency table, you take the information from the frequency table and you turn it into a histogram. Now, it says this is a bar graph. Ooh, that was bad. It says this is a bar graph, but it's not actually a bar graph. There is a difference between a bar graph and a histogram. Now, a histogram uses bars. Let me give you a quick little demonstration. A bar graph, you get distinct bars, look like little buildings or maybe really gnarly teeth, like this. In a histogram, the bars are usually much thicker. See how thin these little guys are? Histogram, usually the bars are thicker, and they're definitely always attached to each other. So, bar graph, spaces in between, skinny bars. Histogram, no space in between, thicker bars. So although it says it's a bar graph, yes, it uses bars, but it's not the same thing as a normal bar graph that we think of. So we're going to start our first couple problems looking at the stem and leaf plot. So, oopsie, skipped a page. There it is. It says here, the number of home runs hit by the 20 baseball players with the best single-season batting averages in Major League Baseball since 1900 is listed below. Make a stem and leaf plot of the data. Now, we're going to do this twice. The first stem and leaf plot we're going to make is going to be what's just called a normal stem and leaf plot. The second stem and leaf plot we're going to make is going to be a organized stem and leaf plot, where we're going to take our numbers and we're going to put them in order. It's ordered stem and leaf plot. So let's start. Stem and leaf plot. So stem, leaf. First thing you do is you find the smallest number. So what is the smallest number? 3. Then you find the largest number. The largest number is, I'm seeing 42. Yeah. So, the way a stem and leaf plot works is you need to use some part of that number for the stem. Now, typically if you have a 2-digit number like this, the first number is the stem. The second number would be the leaf. Now, that is the largest number. That would be 42. The smallest number we have is 3. Now, unfortunately, this is only 1 digit. But did you know that the number 3 is the same thing as 03? So the stem of this is actually a 0, and the leaf is the 3. So the way a stem and leaf plot works is you put the smallest stem on the top, the largest stem on the bottom, and you have to fill in every number in between. So 0, 1, 2, 3, 4. I don't care if the numbers are used or not. In fact, we haven't even looked at the rest of the numbers in our stem and leaf plot. But we want to make sure that every number is included from 0 to 4 as far as our stem is concerned. Now, here's how this works very simply. We go through one number at a time. So this first number, 14, has a stem of 1 and a leaf of 4. Next number has a stem of 2, a leaf of 5. This guy we talked about earlier, since it's a single-digit number, the stem is 0. That's 0, 8. So we've got an 8 and an 8. Ooh, what's going on? Stop. And I'm back. All right. It's got 8, 8, 7, 7, 19, so 1, 9, 37, 37, 39, 39, 18, 1, 8, 42, 42, 23, 23, 4 is 0, 4, 32, 14, 21, 3, 12, 19, 41. Now this is a stem and leaf plot. We're missing one thing actually. And this always has to be there. You need a key. The key in a stem and leaf plot helps you understand what this information means. So the key here is going to say, and I usually just pick this bottom guy here. So I'm going to say 4/2 equals, what does that number represent, this 4/2? Well, that came from the number 42. That way, when somebody's reading your stem and leaf plot you made, they know, okay, that's 42, and that means 41, 37, 39, 32, 14, 19, 18, 14. So they can understand it. So that is our stem and leaf plot. Now, I'm going to make this again, but this time I'm going to make it an ordered stem and leaf plot. Now, I'm not going to start from scratch, I'll be honest. What I'm going to do is I'm going to use this information. So 0, 1, 2, 3, 4. And all I'm going to do in each set of leaves is I'm going to put the numbers in order from least to greatest. So under the 0, we've got 3, 4, 7, 7, 8, 8. Under the 1, I've got 2, 4, 4, 8, 9, 9, 1, 2, 5, 2, 7, 9, 1, 2, and we still need our key. So you could potentially jump straight to this ordered 7-leaf plot from the beginning. If as you're going through you find, okay, the smallest number, then the next smallest, and the next smallest, it can be a little time consuming that way, but it works. You could also, actually this should be a 23. I saw that there's a 23 here, and I think I put 2. Just change it to 23. But you could also go through and make your 7-leaf plot like we did here, and if you wanted to, just to save some space in your paper, erase it and put the numbers in order. That would also work. But most people considered this ordered stem and leaf plot to be better than this ugly mess of a stem and leaf plot. Letter B. Now, letter B, you see we've got some decimals here. So when we're making our stem and leaf plot, we've got to be a little bit different. So we're going to start stem, leaf, draw your stem, and here we go. What is the smallest stem? Well, notice how each of these is still a 2-digit. There's 2 different digits on each of them. So smallest stem is 0. The largest stem is again 4. So 0, 1, 2, 3, 4. You include every number in between. So we have our stem. Now you start adding leaves. So 0, 9. I'm going to try to do this a little bit strategically. So this 1, 9. I'm going to put the 9 out here in case I need to fit some other numbers in between. 45, 47, 23. There's another 19. And a 16. 45. 42. And 12. So when I did it, I still kind of put them in order. Look, each of these are in order from least to greatest. Now, as far as my key goes, I'm going to do 4/5 equals. Now, in this case, it would not be 45. This 4, 5 combination here does not mean 45. It means 4.5. Which is why that key is so important, because that key tells you what these set of numbers mean. Now, one thing I want you to notice, look at the stem of 0. This stem of 0, the stem of 3 has no leaves. It would be wrong to put a 0 in there, showing that there's none of them. That would be wrong. Because by putting a 0 in there, it's making it seem like there's a 3.0 when there's not. So don't put 3.0. Just if there's nothing there, you leave it blank. So that's why you include all of the stems, is it shows you, okay, there's 1, 0 something, there's 4 in the 1 point, there's 2, that's sort of 2 point something, there's nothing in the 3s, and there's 4 in the 4s. It helps you organize your data a little bit. It's a more compact way than listing the numbers. You're able to look at the numbers a little bit easier and just draw some general conclusions. Speaking of which, letter C for you. Go ahead, make your 7-leaf plot, and answer the question. It says the test scores in a small math class were 97, 83, 45, 87, 80, 92, 78, and 56. Make a 7-leaf plot of the data. Which letter grade occurred the most? Go ahead and do this now. Okay, hopefully you're done by now, and let's see what we got. So for your 7-leaf plot, we've got stem, leaf. So these are my numbers. My smallest stem is 40. My largest stem is 90. I need everything in between. So 4, 5, 6, 7. I need a bit more space, I think. 8, 9. All right. Now, let's go through. 97, 83, 45, 87, 80, 92, 78, and 56. So we have our stem and leaf plot. We need to include our key. So the key would say 9/7 equals 97. Now it does say here which letter grade occurred the most. Well, the letter grade that occurred the most, if you think about it, we've got A's, B's, C's, D's, and F's. So in A's, B's, C's, D's, and these would all be F's. Well, the letter grade that occurred the most often was actually the B's. There are 3 B's, 2 A's, 1 C, no D's, and 2 F's. So the letter grade that occurred the most often was the B's. This question comes from the textbook. I'd like you to pause the video, do the problem right now. When you're ready to continue, hit play, and we'll go through it together. Okay, let's see how you did. So, I'm going to start by stem and leaf. Now, since you're only allowed to have 1 leaf per number, the stem in this case is actually going to be 3 numbers long. So you think about it, what I'm underlining here is going to be the stem of each number, because you're only allowed to have 1 leaf for each. So if you look at what I've underlined, the smallest of the stems, I believe, was 178. The largest of the stems, I think, is 181. And you need everything in between, so 178, 79, 80, and 81. Alright, now we go through, and the last digit is always going to be the leaf. So we've got, starting at the top, working our way across, we've got 178, a 1787, a 1788, a 1816, 1792, 1812, and 1788. So that was this first row. Next row, 1788, 1817, 1788, 1787, 1788, 1789, 1803. That was second row. And the last row, 1787, 1790, 1788, 1796, 1791, 1788. And key 1817 I messed up. 181/7 equals 1817. Now, this is a stem and leaf plot. I personally would like this ordered. I think this is ugly and messy, so I'm going to take a couple seconds here and order this up. So I'm going to start at the bottom. So there should be 2, 6, 7. 2, 6, 7. 0, 1, 2, 6. I need 1, 2, 3 7s. 1, 2, 3, 4, 5, 6, 7, 8 8s. And 1 9. So you got 7, 7, 7, 1, 2, 3, 4, 5, 6, 7, 8, and a 9. So this is now an ordered stem and leaf plot. So each number only has one leaf. Everything else in the number is going to be part of the stem. Okay, so that's a stem and leaf plot. The next thing we're going to look at, and the only other example on the paper, is a histogram. Now, to make a histogram, the first thing we got to do is make a frequency table. So it says here, the prices of sandwiches at a restaurant are listed below. Make a histogram of the data. You'll see on the left side of the screen here, I have a little table that has price, tally, and frequency. That is a frequency table. What it's going to do is it's going to tell us how many times the prices occur in this range. So if I maybe start counting, I say, oh, there's, just throwing some numbers in, they're not right. So maybe there's 2 sandwiches that have a price range from here to here. 1 sandwich has a price range from there to there. 1 from there to there, and 4 from there to there. We would then take that information, get our frequency, and then from that, our histogram. So let's do it for reals now. So $4. He's in this category. $4 in that category. $4.50 here. $4.75 here. $4.25 here. $5.95 here. $5.50 here. $5.50 here. $5.75 here. So those are our tallies. Now, frequency is basically you just count the tallies and make a regular number. So there were 3 of them, 2 of them, 0 of them, and 4 of them. So we're figuring out how often you get a sandwich in the $5.50 to $5.99 range. That's what the frequency table does. Now we're going to take this information, this frequency table, and we're going to turn it into our histogram. So first things first is we get our frequency. I'm labeling this side here as frequency. And this side down here would be our price. So this would be the independent variable, the dependent variable. Independent, the price is not affected by something else. The frequency is affected by the price. All right, now, the frequency, the highest number in frequency is 4. So let's plan this out. 0, 1, 2, 3, 4. Yeah, that'll work. 1, 2, 3, 4, 5, 6. So the biggest bar will be up here someplace. That's decent. Now, price. We've got to plan this out because we're not going to, it would be wrong to have the first one here, second one here, third one here, fourth one here. That would be wrong to put your bars like that. So how would it be correct? Well, if we take this space here for the first one, so this is from $4 to $4.49. The second bar would be right up next to it. This is from $4.50 through $4.99. The next bar is from $5 through $5.49. And the last bar is from $5.50 through $5.99. So you see where my bars are going to go. I planned out ahead. They are touching each other. They're going to be right up next to each other. There's no spaces in between. So my first space, from $4 to $4.99, there were 3 sandwiches. You know what? I'm going to make my bars look fancy. Oh, how about... yeah, that's super fancy. There you go. There's my first bar. It has a height of 3, because that was the frequency of 3. In my second category, there were 2 sandwiches in that range, so I make a bar with a height of 2. My third category, there were no sandwiches, so I just don't put a bar there. And finally, in the last category, height of 4, because there were 4 sandwiches. So this is a histogram. That histogram, again, is the representation, a picture of the frequency table. And the frequency table is there to show how often the prices of those sandwiches happen. How many sandwiches are in the $4 to $4.99 range? How many sandwiches are between $5 and $5.49? How many sandwiches are between $5.50 and $5.99? That's what the frequency table is showing, and that's what the histogram is showing. So we did a practice of that. Now it's your turn. This comes from page 833, number 4. It says the average number of days each month with a precipitation of 0.01 or more inches in Buffalo, New York are 20, 17, 16, 14, 13, 11, 10, 10, 11, 12, 16, and 19. Make a histogram of the data. I want you to pause the video right now. Try this on your own. When you're ready to continue, hit play. One thing I want to mention before you actually do pause the video is when you're making your histogram, you want to have between 3 and 6 categories. Think about that. If you're stuck, then start watching the next part of the video, but we'll go through it together when you're done. Okay, so let's see what about our table here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. Well, makes sense because 1 for each month. The range of the numbers is from 10 through 20. All right. So I'll call this inches, and then tally, and frequency. I actually don't know how many categories I'm going to use or how many I'm going to need, but I'm just making space for a couple here. So it would be wrong to go, oh, this is from 10 to 15 and then 16 through 20. For 2 reasons. First off, there's only 2 categories. That's not enough. Second reason is this category is 5 big. This category is only 4 big. One of the things that needs to happen is when you're making your categories, each category needs to be the same size, and there should be between about 3 to 6 categories. So, let's see a better way. Well, I still like starting at 10. So let's maybe try to go for 3 or 4 categories. Maybe 5. Yeah. We'll try this. So from 10 to 13. So next one from 14, so 10, 11, 12, 13. So that category is 4 big. So 14, 15, 16, 17, 18, 19, 20, 21. You'll notice that I don't have any overlaps. This one ends at 13, this one picks up at 14. Ends at 17, picks up at 18. Each category is 4 numbers big. 10, 11, 12, 13. 14, 15, 16, 17. 18, 19, 20, 21. So they're all 4 big. I've got 3 categories. This will work. If you made yours where you went 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Oopsie, 21. That would still work. There would be absolutely nothing wrong with that as your frequency table either. All categories are the same size. They're each 3 big. It covers all the numbers. There's between 3 and 6 categories, so you'd be good. But I'm going to stick with the one I have just because that's what I've already done. Now, tallies. So I'm going to go through my numbers, and I'm just going to make a tally mark where it belongs. So 20 is in that range, 17, 16, 14, 13, 11, 10, 10, 11. Ugh, I was dumb. I was going too quick. I wasn't thinking. When you're doing this, if you get a group of 5, you make a slash like that. That way that's one group of 5. And I think I lost track of where I was. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. 12, 16, 19. So this so far is my frequency table. Now there are 6 here, 4 here, and 2 here. So now when we make our histogram, we get frequency on the side, and we're going to get our inches down here. And let's see, our different categories, I need 3, so I'm going to go 1. That's my first group. There's my second bar. There's my third bar. So I just kind of space it out. So the first bar is from 10 through 13 inches, and then 14 through 17, and then 18 through 21. Frequency needs to go up to about 6, so 0, 1, 2, 3, 4, 5, 6, 7. Alright, now we're ready. Bar. First bar goes up to 6 and over and down. Ooh, I missed. That's better. Okay, second bar has a height of 4. It's about 4. Third bar has a height of 2. And that would be my histogram. So you can see out of this year, the average number of days each month with more than 1 or 0.01 inches of rain, it happened more with the, actually, it's not inches, this is days. What am I doing? That's how many days each month had that much rain. So there were 10 to 13 days each month with that much more rain happened the most. And then the fact that there's like here, there's 20 days that got that much rain or more happened very few. So no, that was not inches of rain. That was how many days each month got 0.01 or more inches of rain. And lastly, the summary. It says, how do I display data in a stem and leaf plot and display data in a histogram? So talk about what's maybe good about a stem and leaf plot, and talk maybe what's good about a histogram. Why would we use a stem and leaf plot? Why would we use a histogram? Go ahead, pause the video right now. When you're ready to continue, hit play, and we'll go through it together. Alrighty, I have here a stem and leaf plots are used to display data as an organized list. I have list in quotes. It's not really a list of information, but it's an organized list. It's a little bit better than a list. And histograms are used to show graphically how often something happens. It's determining frequency or showing frequency. How often it happens, how much it happens. We've got our homework, which comes from page 833, number 3, and 884, number 11. This has been Mr. Henry, and this is lesson 13.7. Thank you for watching. Bye-bye.